Hi everyone, I'm Livia and I'm here today with Radu, our colleague, who is going to talk about a recent automation that he worked on for our internal processes. Thank you all for joining and thank you, Radu, for taking the time to do this.
Yeah, thank you, Livia, for introduction. I will share my webinar in a second. All right. So welcome everyone. I'm Radu Jomir, a software developer from Bytex Technologies, and I am excited to show you something we've been working on that's really changing how teams interact with their Jira data. So today we are going to explore how we build an AI-powered chatbot that can answer questions about Jira issues in natural language. We'll start by looking at the problem we are solving. Then I'll show you the solution, walk through the technical details, and give you a live demo. And we'll also talk about how you can deploy this yourself and the business value it brings. But before we get into the technical details, I want to emphasize something really important. Why it's relevant to use AI in our processes, not just the very large ones. So the beauty of a modern AI solution is that they are flexible, easy to build, and easy to implement, especially when teams are flexible and open to working with new solutions and automation as a way of working. We are showing you this example today in webinar precisely to demonstrate that it's easy to build and find a simple solution to process optimization. You don't need the most complex AI system. You just need the proactive teams that are attentive to gaps and can quickly identify needs. This is about internal culture, teams that spot inefficiencies and have their mindset to build solutions rather than just work around problems. So this project is a perfect example. It's not a massive enterprise system, but it demonstrates how AI can transform everyday workflows and make teams more productive. So let's get started. The challenge. So let's start with the problem. Jira is fantastic for project management. It's a gold mine of data about issues, custom fields, priorities, and project status. But here's the thing. Extracting insights from all the data is really hard. So think about it. When you need to find all Java issues with a budget under 5,000, for example, or when you are onboarding a new team member who needs to understand the current project status, you are often stuck manually searching through tickets, filtering by different criteria, and piecing together information from multiple places. So it's really time-consuming, error-prone, and frankly, not very user-friendly. So this is exactly the kind of problem that AI can solve. So our solution, it's an AI-powered Jira chatbot. So an AI-powered chatbot that uses something called Retrieval Augmented Generation, or RAG for short. What that means is instead of just generating answers from general knowledge, our system first retrieves the relevant data from your Jira instance. Then it uses AI to generate a smart contextual response. The key benefits are pretty exciting. Users can ask questions in natural language, like show me all Java issues with a budget under 5,000. And they can get instant, accurate answers. So every issue mentioned in the response comes with a clickable link back to Jira. This was custom made by us, so we can integrate components in the chat response. In our case, we made all the response links clickable, so the chat can guide the user back to Jira. And because we built it to support custom fields, It can handle things like budget, location, department, or any other custom data your organization uses. So as the best part, this is a real working system that we will see soon in action. Let's discuss about technical depth a bit, the architecture. So our architecture is built around a few key components. We have a Flask web application that handles the user interface and coordinates everything. We use sentence transformers to create intelligent embeddings of the Jira ticket data, which enable semantic search and understanding of ticket content. We integrate with Jira through their API to fetch issues and custom fields. So then the custom fields are mapped through a simple JSON configuration file, make it easy to add new fields without changing the code. And the heart of the system is our RAG pipeline. We use ChromaDB as our vector store to efficient similarity search and LangChain to orchestrate the retrieval and generation process. The tech stack is a modern and well-supported. It's Python, Flask, it's LangChain for orchestration, sentence transformers, ChromaDB for vectoring, and the Jira API itself. Everything is designed to be modular and extensible. All right. Rapid iteration and flexibility. One of the key insights we had while building this is that AI products evolve really quickly. Requirements change, new features are needed, and the system needs to adapt. That's why we focused on building modular, reusable components from the start. So our code is structured so that adding a new custom field is as simple as editing a JSON file. The components are designed to be easily understood by the whole team, not just the developers who wrote them. And this approach has allowed us to iterate quickly, add new features, and maintain quality without getting bogged down in refactoring. So it's a good example of how building for flexibility from the beginning pays off in the long run. Okay, and now the interesting part, a little bit of demo. So now I will just share my screen to start my application, and we will see our application in action. In order to start this application, you just need to cd into the application directory. Our application directory is Jira RAG chat, and you just run the main file by Python app.py. I need to start in a second. All right, so we see the URL for accessing this application is generating in the logs. If we go in our browser and we access this URL, we can see our web application. And now let's test it with few questions. For example, we can type something like, give me all the tickets. All right. So it will give back to us all the tickets that currently we have. So each ticket has a link back to Jira, as I mentioned earlier, and some information about the ticket itself. We can, for example, ask some more specific questions like give me all Java tickets. So it will give us all the Java related tickets. What's the beauty of this semantic search is just the fact that it will search through the content of the tickets, not just a simple text searching. So we see we have Java tickets here. If we click on the link, we can see that our project, Jira project, is opened and we are redirected to the ticket itself. Let's give it one more try. So give me React tickets. And as we see, we got only one React ticket. And we again can click on it and we are redirected to our React ticket. So yeah, that's a beautiful tool, simple but very efficient. I will switch back to my webinar. All right. So discussing about how we build it. So let me give you a quick tour of how this is actually built. The code is organized into a clean modular structure. We have our main Flask application in app.py, which is the main file, which handles the web interface and coordinates everything. The RAG logic is in RAG agent py file. This is where we handle query parsing, intelligent filtering, and the overall retrieval process. And our vector store implementation is in vector store py file using ChromaDB for efficient similarity search. The Jira integration is handled in Jira client. And well, the Jira client itself is just for fetching the issues, the tickets, let's say, from the Jira API. And it handles authentication also. One of the things I'm particularly proud of is how we handle custom fields. It's all done through a simple JSON configuration file. You can add new fields, change mappings, and the system adapts automatically. This modular approach makes it easy to extend and maintain the whole system in design to be production ready and scalable. For example, if I again will share my screen one more time, we can see in our project we have this file, which is the custom field map, where we map our custom fields from Jira to human readable labels. This is because Jira itself, when we create some custom fields, it exposes for us a custom fields and not a human readable label. And in order for our RAG chat to understand, for example, if we ask him, give me the tickets with the budget lower than some amount, it should understand that we discuss specifically about this field. For example, if we go back to our chat and ask him, give me tickets with budget lower than 4,000. We see that we have this ticket where the budget is 2,000 and it's actually correct. So that's the beauty of such custom fields map. So you can add whatever custom field you want, for example, budget, notice period, and so on. All right. Let's discuss now a bit about deployment and scalability. So for local development and testing, it's straightforward. You set up the environment variables and custom fields configuration and just run the Flask application as I showed earlier. And the system automatically downloads the necessary AI models for embeddings. For production deployment, you have several options. You can deploy to platforms like Render or Fly.io. for a quick setup, but for the best performance, especially if you want to run the language model on the same server, I'd recommend using a cloud provider like AWS EC2. So we've tested this on a GPU instance like G4 DN X large, and the performance is excellent. The beauty of this architecture is that it scales well. You can easily adapt it, handle more users, more data, or integrate it with other systems like Confluence or ServiceNow and so on. The modular design means you can swap out components or add new features without rebuilding everything. The business value and use cases. First, it dramatically speeds up onboarding. If we discuss about Jira, new team members can ask questions like, "What's the current status of project X?" for example, and get instant, comprehensive answer instead of spending hours digging through Jira trying to find something. So for manager and leads, it provides real-time project insights. Instead of waiting for reports or manually compiling data, they can ask questions and get immediate actionable information. The custom field support means it can handle any business-specific data your organization tracks. And here is what's really exciting. You can apply the same approach to other platforms. Confluence for documentation, ServiceNow for IT service management, or any other system with an API. So it's basically a framework for making enterprise data accessible through natural language. All right. Yeah, thank you all for joining us today. I hope this has given you a clear picture of what's possible when you combine AI with enterprise data systems.
Thank you so much for your presentation, Radu, for taking the time to put this together. I see that we already have some questions, so we can jump directly into the Q&A. The first question is, and thank you to whomever asked it, how much did it take you to work on this project, and how much time does it save?
Right. So yeah, the building of such project is not taking too much time itself. I guess maybe 2 or 3 months of development should be enough. It's more about creating the filter prompts. For example, in the Jira API in the Jira project that we had, to use this RAG agent, we had a lot of custom fields which requires some specific prompt filtering. For example, we have numerical fields, we can have text fields, date fields, and so on. So there are some work to assemble or create those prompt filtering properly. The time does it save? I would say for an example, for someone in HR team, it could save from hours to like really fast to a couple of minutes. In order for someone to search through Jira tickets, in order to find something specific, it can take hours if there are a lot of tickets. But with such a chat, Jira RAG, it can be fast. For example, a couple of minutes, and you find whatever you're looking for.
Awesome. Thank you so much. I love the modularity and that it can be used for any types of teams. We do have another question, which is, what were your main challenges when you worked on this project? Can you share that with us?
Yes, sure. One of main challenge was choosing the right model. First, we tried to use Olama with Olama 3.2 model for embeddings. And I would say this is a powerful model, but it's kind of huge one. And in this specific context of semantic search, it's quite slow. So in the end, we had to change it for a fast one from Hugging Face collections. They having few models which are specifically for this type of semantic search, and we're using LLM Mini embeddings model, which is really fast. And the earlier request that took us, for example, 40 seconds, now it takes about 5 up to 10 seconds. So it's quite different and it's really fast. The other, let's say, challenge part that I encountered was the deploy of this application. As we mentioned, the application is resource consuming. So either you can demo such application locally, or you have a work space where you can deploy it, and that workspace should be a paid one, because most of the platforms that are offering, let's say, free tier workspace won't be enough in terms of resources to give you a successful deployment. So yeah, this is a bit of resource consuming, but it's worth it.
Awesome. Thank you so much for your answers and for the candor, Radu.
Yeah. If you are interested in trying this out, we've made the code available on GitHub, and I'll be happy to walk you through setting it up. We are also offering free consultations to help you understand how this approach could work in your environment. The future of enterprise software is conversational, intelligent, and accessible. So we are excited to be part of that transformation, and I hope you are too. So feel free to reach out with any questions or to discuss how we can help you implement something similar. So thanks again.